Bismillahirrahmanirrahim. Welcome to Easy Learn. This is the episode 4 of network analysis. We are discussing the topics in the previous discussion about the uh, relationship of the conceptual schemes. First scheme is the based on the thinking on what we can say simply atomic theory, that every substances are made up of the atoms. While in this third episode we discussed the second portion of this thinking based on the another conceptual scheme, which is the conservation of the energy, which says that energy can neither be created nor destroyed, but it can just only changes one form to another form. And in today's episode we are going to discuss the and related to previous discussion, that is the electromechanical energy conversion, electrochemical energy conversions, MHD energy conversion, photovoltaic energy conversion. These are the four different types of the conversion we discussed in the previous section. The function of each of these means the function of each of these different sources that we discussed. What sources that we discussed? Conversion sources in the previous episodes. In the previous episode we discussed the conversion of different forms of the energy into the electrical energy. So these sources what we discussed in the previous section, but I also repeat them: electrochemical, mechanical, MHT and photovoltaic. These are the different function. The function of each of these different sources of electrical energy is the same in terms of, so this is of F of energy and charge. So there is a same actually function is the same, both there is the same relationship of each sources. Not here that we can say if we are going to convert the mechanical energy into electrical, there is a different relation of energy and charge, their function is different, while in thermal there is a different, or photovoltaic there is are different. No, the formulas we are going to use develop, they're actually working on the same relations with the same accuracy everywhere. So their function, we can say simply energy and charge, they are behaving in the same context in every platform. So we in today's episode we are basically going to focus on energy and the power and their relationship between them, what the basically relation is between power and energy in one form of the battery. This is the one example that we decided to consider in today's lecture. This is the first form, one form of the battery. Two metallic electrodes, one of zinc and one of copper, are immersed in dilute sulfuric acid. So this is the scenario. Look like suppose we have a major structure here and another boundary, just making it more tighter. Let's consider this, that this is a dilute sulfuric acid, means it is not in pure form, it is impure mixed with water to make it thinner solution. This is the dilute sulfuric acid to store the charge in it. What is basically charge? There are charge. Whenever I'm going to consider charges, you must have known that there are ions. Ions are basically, first let's recap, this is the atom, and in atom if there are two electrons, simply two electrons, then there are two protons inside the nucleus, what I told you in the first episode, because the number of protons is equal to number of electrons to balance as a whole and make sure this as a whole is a neutral. While if an electron leaves, the atom is no longer neutral, it becomes the excess, because protons can't leave, the proton is still 2 but the electron is now 1. So overall the net charge is positive, which we can simply say it is an ion, it is a positive ion. If an electron is accepted, then we can say it has no negative charge is increased, and overall net effect it becomes negative cation and or just negative ion. So these are the ions which carry charge. Then a charge there is a net charge on these atoms. They can be now they can now travel, they can now attract or repel due to the forces of attraction or repulsion between the charges, so they are useful for us. In case of the battery, there is a dilute sulfuric acid, and if we are going to use here two metallic nodes like this one, first one is zinc and then copper, are immersed metallic electrodes, well immersed half almost in the dilute sulfuric acid. The formation of zinc and copper ions started when they are dipped, and there is a charged material. Always work is going to start when they are dipped inside this solution, and there are ions created. Like here, suppose we can say like positive ions are collecting on this terminal and it will behave as a positive, and these are ions, or it's simply charge. This is the charge, because now ions are, now I'm calling it as a charge. There is a huge charge that is sticked across these two electrodes, different types. Then there is a question: if somewhere the energy comes from somewhere and push these charges to go around the external circuits and complete their path. Like if I'm connecting here a bulb, simple, this is a bulb and it can produce a light if it is connected to the suppose positive negative sources. Oh my god, I'm sorry, I draw the both, these are negative, because both can't be the same charges. If there are the positive ions are collected on this terminal, these are the negative in excess. So from negative going to travel, positive coming toward from here this side, which means that the overall the charge is moving like that from here toward here and going completing a path through external circuitry. But for that it need energy. Energy is provided to these charges. From where this energy comes from, and when this energy is permanent, it will still continue the cycle without any difficulties, or what factors are dependent on this. We are going to discuss all these things in today's episode. So let us consider this first picture diagram here. This is the positive terminal and here is the negative terminal. Device for the supply energy to charge bodies by conversion of the chemical energy. Here the chemical energy is converted into electrical energy through this process, and there is an external circuitry. This is the same diagram but I am trying to draw in the previous slide. Energy is supplied to the charge by the difference in the energy of the ionization of zinc and copper, because they're the two electrodes used, so different type of ions are produced in this structure. So they both the charges, the ions, the induced in this structure due to the different metals like zinc and copper. So the reaction is they both have, if these metals have different ionization energy, so it means that when the chemical reaction of their charges happen, they are going to met each other in this dilute sulfuric acid solution. Then there must be ionization energy difference. Like suppose theirs is 5 and the other one here is 10, then 10 minus 5, there is a difference of 5. It means that the ionization energy difference is counted. Energy is supplied to the charge, but the difference in the energy of ionization of zinc, and so difference counts. If there is a high difference in the energies of copper and zinc, their reaction when occur, so higher the difference, higher the energy, higher the output voltage. Here if we measure basically energy, simple we can say. Once the battery circuit is closed by the external connections, like I'm connected here a bulb in the previous slide, when the external circuitry is connected, the chemical energy is expended as a work, then the work is started by the chemical energy for each unit of charges. All the unit of the charges, like suppose this is the 1 unit, they are all available here. There are the different units of the charges. Then who is providing this enough energy to all the units of the charge to move through and pass the external circuitry, though go and complete your paths? This comes from the ionization energy difference of the chemical reaction, and which we can simple say the chemical energy is expanded means chemical energy, this chemical energy is basically expanded to as a work for each unit of the charges. So basically chemical energy is responsible for all this, and the ionization energy basically is a process, but simply chemical energy is responsible, is expanded to as a work is done by the chemical energy for each unit of the charge. And when the chemical energy is reduced but done working again and again, then charge of course will not be able to continue this path. Then if the ions energy of the ions is decreased, then we again charge this battery. If this is a rechargeable battery, again ions are produced with having a high and enough enough difference, then higher the voltage again rise, voltage level is again raised, and then it will again continue it's to follow this same pattern until the difference becomes zero between the two ions ionization energy of the two different ions. So we can develop a definition from this previous slide by using the correct words for the sake of the definition. The quantity energy per unit charge, or identically work per unit charge, is given the name of voltage. Simply, what is voltage? Basically it is the energy. Voltage is a pressure, a voltage is a energy that is applied to per unit charge. I draw with the help of the boxes in the previous slide. These are just to show you a per unit charges. This is 1 unit, second, next per unit. So the energy that is supplied to per unit charge, for example we are supplying energy to this charge, that is 5, energy supplying to this again 5, so this is overall the voltage is 5, because energy is supplied per unit, not to all of these per unit charge is counted. Identically we can say work per unit charge, energy and work is same thing, is given the name of the voltage in this equation. So V is equals to W over Q, means voltage is equals to work, W stands for work done per unit, Q is per unit charge divided in the denominator. Voltage is directly proportional to the work done. If more the work is done, then higher the voltage, higher voltage level automatically definitely rises. The less if the charges are inverse relation with the charge. The W is the W is for the work in joules, Q is the charge in coulombs, and V is in volts. And voltage also comes from the idea of the Alessandro Volta, who is responsible of many important discoveries and research. So for crediting him, this name is his name is still used to as a symbol. Okay, now we are going to define the power voltage in terms of the differentiation, because if you remember the current we define also it in terms of the differentiation. Differentiation is basically the actual definition when we are going to relate two terms with respect to the another term. We are going to use the differentiation for difference between the two terms. The lower term in the denominator is considered as a standard term, like here work is equals to dW over dQ, means that voltage is equals to change in work done divided by change in charge. D over dQ means derivative of work done with respect to D. In the denominator we will say with respect to, this is taken as a standard, the charge. If the more or higher the charge, the change, higher the work done. It is related to them inverse relation. I just said the wrong thing. And the higher the work done, the lower will be, because these are the inverse relation, and we are going to interested in this relation. So this is the reason why. Actually this is very easy to remember, nothing new. Just type here D. D stands for derivation. This cannot be cancelled out. Of course some student might think that this is cancelled out. This is actually derivation. We are not going to say this is simple D. dw over dq, and if there are the values of these two terms, of course then we can use this derivation for the calculation purposes, and we are going to use this in the coming numericals. The voltage of an energy source is sometimes described by the terms of the electromotive force, abbreviated as the EMF, and in the electrical literature, EMF is most electromotive force, and it is discussed when we are using or induced voltage. Voltage is induced by the Faraday law in the alternator. Then we discuss the EMF, electromotive force. Like here, this is the north-south magnet, and this is the simple. A coil is rotating in the presence of the electromagnetic field. When a coil is rotated and cutting the magnetic field lines, an EMF is induced in the coil, which is responsible for overall, we call this as a EMF, electromotive force. So there is a force, and I don't like it. We are avoiding this designation voltage as a force, because it is misleading us. It can mislead us. So right now just focus this one. If the differential amount of the charge dq is given, a differential increase in the energy dw, the potential of the charge is increased by the amount dw over dq. So this is the next formula you have to write down in your notebooks for the later on use. So what is the power? Remember that power is the product and overall net effect. These energies, voltage, current, these are the single terms, but when we said power, it is the overall effect, overall energy. And now how we can relate the power and how we can define power is equals to voltage and multiplied with the current, potential multiplied with the current. Potential or voltage, same thing. If the potential is multiplied with the current, which means that power is equals to voltage multiplied by current. In other words, in our language, in the networking language, we are going to define this as like this is voltage. Right now we define the voltage as a work done per unit charge. So W over Q. For the case of the derivation, just use D in the upper and lower terms with the append the D for the both quantities, like in the case of the current in the previous slides we defined. So what is the I? This is the value of V. Substitute the values of V. dW over dq is the value of the V. This is the value of I. V multiplied by I. I is the current, which is dq over dt is equals to dw over dt. Because very simple conversion, this can be cancelled out, and dw on the numerator and dt in the denominator is equals to p. So this is another formula. Write down in your notebooks, but you can easily derive this formula very easily if you remember already the voltage and current. This result is seen to be the time rate of change of the energy. This says that time with respect to time. Now power is with respect to time. If the rate of the change of energy is higher, the more the power in the less time. If the rate of the change of the energy is low and it takes more time, then it means that the overall power is low. Power is the product of the potential and current. So let us now take the integral of these two terms. Energy is a function of the time, can be expressed by integrating this equation. Why not we are now going to define a relationship between the power and the energy. This can be done by considering this equation. Power is equals to dw over dt. dw over dt is equals to power. Just take dw at the right place. Don't do anything. This is p and multiplied dt. From where dt comes from, dt just go to the other side, and when we are going to take the dt toward right hand side, it will be change its position from denominator towards the numerator. Very simple maths. dw is equals to now p dt. So taking the integral here on the both sides integration, this integral and this d is cancelled out here. W is equals to integral p multiplied with d t. And here if the t, it means that with respect to time t, you know that the power change in power we are interested, work done is equals to total energy or work. Because we are interested in energy, we are using this energy term right now. So total energy at any time t is the integral of the power, integral of the power. So this change in energy from time t1 to time t2 we have to mention out here, like this is the t1 or this is the time t2, two time limits defined. But here in this confusion, their student might confuse, because here is t. Sometimes we can also write here minus infinity, because this is understood in many cases. Minus infinity means that in any circuit, the prior to the turning on of the circuit, or prior to our working or doing any task, like suppose that if there is a circuit and I'm going to turn it on and let's see what happens, then before analyzing it is off. So minus infinity is used at time before doing or before closing the circuit. So this is a term can be used. This is the time, present time can be used, and upper and lower limits, you know how to better calculate. These can be defined. And p stands for the power generally. And here in some books you might found it like w is equals to integral sign, and they are using like t1 and t2. But to avoid further confusion, they are using the dummy variable like x, which can be used anytime anywhere. This is the power. Here they are using their x, because x is the value of the power which is going to derivative with respect to x. So this can also be seen here to avoid the confusion. Sometimes in some books you might see this one. So this is the, I think, end of today's lecture, and episode 4 is here. We are going to continue the discussion in the next lecture. So stay tuned, watch and grow. Allah Hafiz.